Exercise 1.13, last exercise. What says the following: Z is 2 plus I, U is minus 4 plus 3I. On the argon diagram, plot Z, plot IZ, I squared Z, and I cubed Z. So here's what we got to do. We got to, first of all, Z is 2 across, 1 up. 2 across, 1 up. This is the location of Z. Then what it wants me to do next is, it wants me to find out what IZ is. It wants me to find I squared Z. And then finally, I cubed Z. Now look what happens here, guys. Okay, this is very important. They love asking this question. I into 2 plus I. Now look at this. I into 2 plus I gives me 2I plus I squared. Now what is I squared again? So it's minus 1 plus 2I. Now look at minus 1 plus 2I. Minus 1 plus 2I is here. Okay? Now, what happens is, if I was to draw a line, what happens is when you multiplied by I, you rotated the point around 90 degrees. When you multiplied by I, the old point was here and the new point is up here. When we multiply by I again, I'm expecting it to be out the other side at 90 degrees. So let's see if that happens. I squared is what number, guys? So it's going to be minus 1 multiplied by 2 plus I. It's minus 2 minus I. Now look at this, guys. Minus 2 minus I. Minus 2 across, 1 down. And as predicted, it's now rotated another 90 degrees. It was here, and now it's gone up here. The next one should be located down here if we're doing things properly. So let's find out. The next one is I cubed. Now what is I cubed, guys, in terms of I?
Minus 1I.
It's minus 1I, because it's I squared times I, which is minus 1 times I. And then we're going to get minus I multiplied by 2 plus I. And what's minus I times 2? Minus 2I. Minus I times plus I. Minus I squared, which is the same thing as 1 plus 1. This number here is 1 minus 2I. How do you plot 1 minus 2I on the graph? 1 across, 2 down. And as you can see, what happens is, it has caused it to rotate another 90 degrees. Now guys, exactly the same thing happens for part B. Okay? I'm just going to do the Z parts as opposed to the U parts, okay? Now, describe the position of I for Z. Now here's an interesting one. I for Z. I for is the same thing as what, guys? So I for Z is the same thing as I for multiplied by 2 plus I. Now what is I to the power of 4? It's I2 to the power of, which is minus 1 to the power of, which is 1. When you multiply a number by 1, do you change its position or its value? No. So the answer is still 2 plus I. Now look what happens. We were here, and then when we multiplied by I, we went back up to where we started from, which is I for Z. So I to the power of 4 Z. Basically, when you multiply a complex number by I, it rotates 90 degrees. Multiply it by I squared, it goes 180. Multiply it by I cubed, 270. Multiply it by I4, it goes back where it starts from. Okay? Happens every time. Alright. Describe a transformation which is not a rotation that maps IZ onto I cubed Z. So what I gotta do here, just rub everything out for a second. Now, IZ is a transformation, alright, which is not a rotation. What we did here today was a rotation. You can rotate 90 degrees by multiplying by I squared. Every single time you multiply a complex number by I, it adds a 90 degrees rotation to it when you draw it out. However, in this one here, okay, what it wants me to do is this, guys. Okay? What it wants me to do is, this one here is I3Z, and this one here is IZ. how do we turn IZ into I3Z? Let me show you. We go down 4 and across 2. Yeah? That's what's called a translation. Moving the point across and down. So this is what has to happen, okay? If I want to turn minus 1 plus 2i, I want to turn that into this one here, which is 1 minus 2i. Look what I have to do. I have to take away 4 from the y-axis because I have to go down 4, yeah? That's minus 4i. So I have to take away 4 from the y-axis. That's minus 4i. And I have to add 2 onto the real value, which is plus 2. So your transformation is going to be add on 2 minus 4i. Brings it down. Okay? Next part. Name the image of U under central symmetry in IZ. Okay, I'm going to have to write down U and IZ this time. So there's IZ here. IZ is here. And we're going to write down where U is. What's the value of U? Can anybody tell me? It's at the top. Minus 4 plus 3i. Now guys, U is in green. Okay? Now what central symmetry means is you see how far it takes you to get to the point that you have central symmetry in, and you go the same distance out the other side. So right now, Ken, down 1 across 3, down 1 across 3, and you end up back at 2 plus I, which is the same thing as the point Z. Name an image of U under central symmetry in IZ. The answer is Z. Okay? Explain why IZ and I5Z can be represented by the same point on the same Argand diagram. What is the difference between IZ and I5Z? How many I's are in the difference? I to the power of 4. And what did we say about I to the power of 4? 1, 2, 3, 4. I to the power of 4 consists of a full 360 rotation, which means you end up back where you started. That's why. So, if I asked you I2Z and I6Z, what could you say there? The difference is I to the power of 4. This causes a full 360 degree rotation. What happens if I said this? I3 and I6. How much am I rotating this time? 3, isn't it? And what's 3? 90, 180, 270. Okay? Now, W equals 2IU. Give a geometrical interpretation of how to find the position of W on the Argand diagram. Well, to find W, what we're going to do is we're just going to multiply 2I by U. So 2I multiplied by U, which is 4 plus 3I. So we're going to multiply it. If you look at U's original position, it's here, isn't it? Yeah? And then if we multiply it out, the I is going to cause what, guys? The I is going to cause a what type of rotation? What's I going to do? I is going to cause a 90 degrees rotation. The 2 is going to make it twice as long. So that's what happens. So that's what happens here is we're going to get minus 8I plus 6I squared, and that's going to minus 6 minus 8I, and that's going to be all the way down here in this direction here. Oh sorry, no sorry, minus 6 is here, minus 8 is all the way down here, so it's going to be all the way down here, twice as long with a 90 degree rotation. I'll give you another example, guys. If I did this to the number, if I did 3I, what would happen then? 3I. If I multiplied it by 3I, what would happen? 3 times as long, and the I, 90 degree rotation. What happens if I did this? Okay, I multiply this number by, let me see. Sorry, I multiply this number by 2I cubed. What would happen? I cubed is what type of rotation? 1 1, 2, 3. 270 degree rotation. And how much is long? Twice as long. Does everybody get it? No. Alright, I'll do another one afterwards. Alright guys, use your diagram. Explain why u is bigger than z. Explain why the modulus of u is bigger than the modulus of z. Look at this. Here's the modulus of u here, represented in red. It's represented in red is the modulus of u. Do you see it? Modulus means length. So modulus of u is represented in red. The modulus of z is represented in green. The reason why the modulus of u is bigger than the modulus of z is it's a longer line going to a point further away from the origin. We'll do one other one. Okay, number 6, and then I'll set you on your way. Now guys, let z be 2 plus I and w be minus 1 minus 3i. Plot z and w on the argand diagram. 2 up, 1 across being z, and then minus 1 minus 3 being w. Is everybody with me at the moment? Even if you're lost thus far, you're with me now on this one. Okay? Verify that the modulus of w minus z equals 5. Okay, what is w minus z? W minus z is minus 1 minus 3i minus z, which is 2 plus I. What happens here, guys? Minus 1 minus 2? That's going to be minus 2 minus I. So what is it? It's going to be minus 3i minus I, minus 4i. Now we have to get the modulus. Okay? So how do you get the modulus of this number? Square it off. Minus 3 squared plus minus 4 squared is 5. It's 5 long. Okay? Draw a set of k of all complex numbers such that each distance is a distance 5 from z. A distance 5 from z. Now here's the hard one, guys. Distance 5 from z. Now, if you imagine a distance of 5, okay? A distance of 5 can be done in the following way. If you take Pythagoras' theorem, okay? And you want to find out 5 blocks. We just did it there a second ago. When we got the square root of 3 squared plus 4 squared, the distance was 5. If we use 3 and 4 in any direction, we find it something that's a distance 5 away. So for example, look, go 3 across, 4 up. That's K1. 3 across, 4 up. You happy with that? Because when I do Pythagoras' theorem, what's going to happen? It's 3 here, 4 here, and when you do Pythagoras' theorem, it'll turn out to be 5. What about 4 across? 3 down. So what about 4 across, 3 up? Same deal, isn't it? It's 4 across, 3 up, and that gives you 5 as well. What about this side? 3 across, 4 up. We could also go 5 directly up, couldn't we? 1, 2, 3, 4, 5. We could do it that way as well. We could also do 4 across, 3 up. So 1, 2, 3, 4. There is there. Okay, let's go again. 5 across. K6. What about next one? 3 down, 4 across. K7. The next one. 4 down, 3 across is already marked there. K8. Go 5 down. That's K9, then 3 across, 4 down, that's K10, then 4 across, 3 down, K11, and then finally 5 directly across. What type of object did that make there? So, if you're looking at the object to make, look at this. More or less made a circle. Actually, should be 5 away each time. Oh, sorry, I didn't mark it exactly on the line. So it is meant to be a perfect circle, okay? This one here, did I do it right? Oh, sorry, K5's in the wrong position. It's there. Okay? So you can see that it's a circle. Each point is 5 away from the middle. Okay? What geometrical figure is represented by K? a circle. It's all the points that are 5 away from Z. Let U be 2 minus 2 plus 4i. Investigate, lads. Shh. Do you understand what it means by K? K is a circle. Is this point on the circle? Minus 2 plus 4. Is it on the circle? Yes. Write the image of W under central symmetry in Z. W is located here. What's central symmetry again, Luke? You find out how far you have to go to Z. You have to go, what's it, 3 across, 4 up, 3 across, 4 up. Write the image. The image is going to be 5 plus 5i. Okay guys. You guys now, I'd like you to try all questions.